Hello everyone, and welcome to this project on diabetes detection with zero coding. In this project, we are going to train a classifier model to detect whether a patient has diabetes or not. So what we're going to do is that we're going to use DataRobot, and essentially, if you guys wanted to learn more about DataRobot and its capabilities, it's actually a super powerful tool. You should be able to find all the details in the course. But right now, I'm just going to show you how to upload the data, how to train multiple models, and also how to deploy the best model out of all of them. Okay, so the data set is used to predict whether or not a patient has diabetes or not. And here is the acknowledgement and the data source as well, if you guys wanted to check it out. And we are going to use a series of features from these patients, and here is the output. And as I mentioned, the output is simple binary classification. It's either 0 or 1. The patient has diabetes or not. Pretty simple. And this data set primarily focuses on female patients who are at least 21 years old and also are of Pima Indian heritage as well. So here are the inputs. We're going to take a look at the number of times the patients were pregnant. We're going to take a look at glucose concentration levels. We're going to also take a look at the blood pressure as well. And we'll also take a look at the skin fold thickness. We will also going to use the insulin levels as well, and all these are measurements. This is a 2-hour serum insulin. We will also feed in the model with the body mass index, or BMI for short. And we're also going to feed the model with diabetes, what we call it P-degree function. And I've included a little bit of kind of description here for you guys. So simply, this is diabetes P-degree function represents how likely Pima Indians would get diagnosed with disease by extrapolating from their ancestors' history. Okay. And then finally, we are going to have the age, and that will be in years. So what we're going to do, and that's the power of DataRobot, is that we can simply take all these features, all the entire data set, and without doing any, I would say, without writing any code, you can just take that data and just upload it to DataRobot, and it will just going to do the trick for you. We're going to perform exploratory data analysis, feature engineering, data cleaning, model training, hyperparameters tuning, and as well model deployment, which is again super powerful. Okay, so let me go ahead and show you the DataRobot part. All right, so here we go. Here I have the DataRobot open. And please, again, if you wanted to know how to set up your account and do all of that, I've included detailed video explanation in the course into how to set up an account, how to get approved, and all of that. And please note that here, this is just a trial version, and it's only available for 2 weeks. Okay, so here we go. Here I have, once you open the DataRobot, you will essentially be, you have to make a choice here, essentially. So you have to either perform data preparation, or machine learning development, or machine learning operations. So please go ahead and select machine learning development, because that's essentially what we wanted to do. We wanted to perform AutoML. We wanted to visualize essentially all our models, and we want to also explore the data too. So please go ahead and click on it, and here we go. And you should go here and say create new project. And please know that here there are tons of examples available for you. So if you wanted to explore, let's say, projects in security, for example, or maybe in the manufacturing, or maybe in fintech, or telecommunication, or insurance, or banking, there are so many open projects available for you here. But what I've included in the course package is, here we go. Here I have the slides, and I've also included the diabetes data. So please go ahead, and all I want for you to do is to just drag and drop the diabetes data to here. And that's all what you need to do, which is again super powerful. So on the right hand side here, you should be able to see that the status that we are uploading the data, and then we are reading raw data. This is just a quick, I would say, analysis on the data. And then DataRobot will perform exploratory data analysis for you. And what you guys should be able to see right now is that you should be able to see all the features, all the inputs to the model have been processed. And here we go. So if you scroll down, you should be able to see here all the features that I've mentioned. So here the number of pregnancies, the glucose level, the blood pressure, skin thickness, insulin, body mass index, diabetes pedigree function, age, and outcome. Okay, so please note the first task that I want you guys to do whenever you deal with DataRobot here is to specify the target. And you should be able to see it in many locations. And that's a very important, I would say, piece of information that you need to feed in to DataRobot. You wanted to specify what is my input and what is my output. It's just a basic input that you wanted to provide here. And you can do it in many locations, in fact. So if you actually check out here, you can say select target. When I say select target, that means I'm selecting the output. What is that I'm trying to predict here? And if you guys scroll down, you should be able to see that the outcome column, that's the column that I'm trying to predict, essentially. So here, you can do it here, or you can go here and say enter your target, or another way of doing it, just everywhere, is that you can just say use as target. You can specify which feature you are interested in, or which of these, I would say, columns you're interested in, and you use it as a target. And please note that actually, if you open up outcome, here we go. Here is essentially, that's my target, and that's what I'm trying to predict. I'm trying to predict whether patients have diabetes or not. Again, it's either 0 or 1. So what I wanted to do is just say use as target. And before I click on that, please know that here, all what you need to do is that you need to upload the data, as I mentioned, and then next you need to click start. And that will do everything for you. But you guys will notice that here start is not, I would say, allowed. Like you can't just go here and click start because you need to specify the target, okay? And that's what I need to do here. I'm just gonna say use as target. And once you do that, you should be able to see that now start has been activated. And you should be able to see as well here a nice visual representation of how many samples do we have that belong to both classes. So here is class 0, here is class 1. So it looks like I have around 500 samples that belong to class 0. And here I have around 250 samples approximately that belongs to class number 1. Okay, and again, this graph is pretty much the same. Let's go ahead and explore as well additional features. So if you check out pregnancies, this is the distribution essentially for my a number of pregnancies. If you check out the glucose level, here we go, this is a distribution. So it ranges between, let's say, 60 and 180, around 200 approximately. And you should be able to see as well here, if you want, the mean, the standard deviation, the median, the minimum, and the maximum as well. And you should be able to see as well the variable type, if it's numeric or if it's like categorical and so on. And here it shows how many unique elements do we have in our data. So if you check out, let's say, the blood pressure, here we go. This is a distribution of our blood pressure. And another point as well to highlight is that here it's DataRobot, it just spits out for you kind of what we call a data quality assessment. So if you click on view information, it can tell you if there is any, let's say, missing data, or maybe if there is, let's say, excess zeros, for example, that has been detected, or maybe if there is outliers. And again, I really like this feature because it's like what we hate as data scientists is any black box model. So essentially we hate that we just feed in, data to an algorithm, for example, or a tool like this, without knowing actually what happened behind the scenes. We want to have transparency. We want to know what actually happened. And that's the power of DataRobot, that it can actually tell you what's happening behind the scenes, which is, again, pretty powerful. So if you guys can see here, again, because these are very simple, I would say, or basic issues, I'm just going to simply ignore them for now. Just going to say dismiss, and you should be able to see that this is the, I would say, the flag, but again, we ignore them for now. Let's go ahead and check maybe the body mass index. Here is the BMI. And if you check out the age, for example, this is a distribution of our data. And as I mentioned, the minimum age for this study was 21 years old. Okay, so what I could do right now is simply just go ahead and say, well, click start, and that's all what you need to do. And what DataRobot will gonna do, it's essentially is going to train multiple models with various feature engineering and while performing hyperparameters tuning as well. And you guys can go ahead here under models to be able to see what we call it the leaderboard, like which model has been trained and which one is the best out of all. Again, like really powerful, extremely easy, I would say, to use. So on the right hand side, you should be able to see that here we load the data set and prepare the data. And you guys should be able to see that here, these are all the models that are being trained. So here we have Keras Slim Residual Neural Network Classifier. So that's just an artificial neural network, essentially. Here we have Gradient Boosted Trees Classifier. And these are what we call it XGBoost. And please note that if you guys check out the course, you should be able to see a ton of details on XGBoost and on artificial neural networks as well. And I would say the training might take maybe like 5 to 10 minutes approximately. And the training here is being performed on the right hand side, showing you all the different models in queue and all the models that have been trained already. So what I'm going to do is I'm going to simply pause the video, and I'm going to come back again after these models are trained. All right, so as you guys can see here, the training has been complete. And you guys notice that here we have actually 14 models that have been trained already with the data. And here are a lot of the models that have been trained on what we call it the leaderboard, essentially. So for example, the best model that the DataRobot came up with is what we call it the random forest classified model. And there are so many, and you guys will notice here that if you just hover on top of these icons, you should be able to see that this is, for example, a Python model. If you, let's say here, there is another random forest classifier. Here there is extreme gradient boosted or XGBoost. If you scroll down, there is gradient boosted trees as well, but these ones have been developed with R model, with the R language. And if you scroll down, you should be able to see that the artificial neural network has been trained using Keras and TensorFlow 2.0. And simply Keras is just a high-level API for artificial neural network development and deployment, and it's actually a super powerful tool or API. And if you see here, these are DataRobot models here as well. So essentially, you are leveraging so many different models that are written in so many different languages, programming languages as well, behind the scenes. So let's go ahead and explore the best one. So if you just click on it, here we go. So first, here is the blueprint of the model. Here simply it's indicating that this is the data. Here we have tree-based algorithm pre-processing. And if you click on it, you should be able to see that this is, for example, a proprietary DataRobot developed algorithm. So we actually don't have access to that algorithm here. But if you check out the random forest classifier and you click on it, you should be able to see a ton of documentation here available for you. And if you actually read what's written here, it's just stating that this random forest classifier model is based on scikit-learn or sklearn. And sklearn is a machine learning library that's actually pretty famous in the data science and AI ML community. If you open the documentation, if you guys wanted to read about it, here is the random forest classifier documentation showing here all the different hyperparameters. So all these parameters are actually tunable parameters. So you can go ahead and tune these values to try to improve the performance of the model. Okay, so here is the blueprint. And if you check out, there are so many information. So for example, if you check out, let's say the understand piece of it here. So here it's simply telling you that these are the most important features that have an impact on the model predictions. So the glucose level is one important feature, followed by age, followed by body mass index. There is the diabetes P degree function, the number of pregnancies as well. Apparently it has an impact on the whether a patient has diabetes or not. and skin thickness, blood pressure, and insulin at the end. If you wanted to as well, maybe open the scribe that will show you, actually, if you check out, let's say, the model information, here you should be able to see the model file size, here the prediction time, and finally the sample size as well, showing how we did the division between training and testing. So we had 768 rows, and they have been divided into 768 rows for training and 123 rows for testing. And what I could do right now is, what you guys see here is it shows that this model is simply recommended for deployment. So it's also have been prepared for deployment. So what you guys could do is that you can simply go ahead and just deploy that model really easily right now. But before we do that, I just wanted to show you a couple of other KPIs. So here we have the predictions coming out from the model. Here, these are the blue ones here. And the orange curve is the actual. So you will see that the model predictions actually match pretty much the actual values. Of course, there is some, I would say, discrepancies here, but overall the trend is pretty accurate. If you check out the ROC or ROC curve, here is the ROC curve. And please note that I'm not going to cover the details of all these KPIs here in this bonus case study, because in the course, we have actually included a ton of details on what these graphs actually mean, what is the ROC curve or receiver operating characteristic curve. So please go ahead and check that out. But from a very high level, basically the area under the curve using that classifier model is around 0.83, which is, I would say, pretty good, given that 0 is a terrible classifier, 1 is our best classifier model. And simply, if you have a model that goes through that line here, that means it is a random classifier. As long as you have a curve or ROC curve that is kind of skewed towards the top left corner, so if it's like going here or going like that way, that green line here, that's an indication of a good model, of a good classifier. That means the true positive rate is actually much higher compared to the false positive rate. And here is as well a couple of graphs. Again, I explained these in great details in the course, so please go ahead and check them out. And you should be able to also see here the confusion matrix showing you the number of true positives, true negatives, false positives, and false negatives. So again, it looks like the model did an okay job, I would say, given that data. And please note that this data is real world data. So generally in the real world, you're not going to be able to see like a clean separation between the two classes. Okay, so what I could do right now is I wanted to go ahead and actually deploy that model. So in order to do that, you can just simply come here and click on Deploy Auto Model. So that will essentially deploy it for you. And if you check out Auto Model here, you should be able to see that now the model has been deployed. And what you guys can do is that you can simply create an application for you to be able to make inferences on that model. So if I say create application and you select the predictor, and if you say deploy, actually super easy and super powerful. Here we go. So now the model is being deployed, and what I could do next is I can simply just maybe like upload a couple of data to see the model performance, to see how the model is classifying the patients. And in the course package, I've also included an Excel sheet that is entitled Diabetes Testing Data. And that will be the Excel sheet that we're going to use to assess the performance of our model. So here we go. So now the model has been deployed. I can simply say open, and that will create here an application for you. So here I have the diabetes data set, and these are essentially testing data set. So the model has never seen this data before during training. So you have pregnancies, glucose, blood pressure again, and so on. And I can simply just go ahead and drag and drop the Excel sheet, which is diabetes testing data, to my, let me actually show you. So here we go. Here I have my diabetes testing data. All I need to do is to simply just take that data and just drag and drop in here. And basically right now we are actually making inference on the deployed model. Okay, so you guys will see here, this is the new record. That's the first record. So here it's indicating that this data set is actually normal. So the prediction is normal because it's in the top 52 percentile. And you can also come down here and see the values. So here I have the BMI, the body mass index, glucose, age, and so on. And it can tell you what is essentially the class accordingly. If you check out the next one, well, it's telling you this prediction is high because in the top 4.6% of historical data. So simply here, it's telling you that based on these features, this has been classified as 1. And if you guys wanted to verify basically the outcomes that is coming out from the DataRobot, here we go. So this is, for example, the second sample here, which is indicating pregnancies 2, 197 glucose level, blood pressure is 70, skin thickness 45, and so on. So this is essentially this row here. And the outcome should be 1, and the model has actually predicted 1 as well. If you check out the next one, here we go. Here we have 67.01. Here we have 14.47 and 59.65. So essentially these are the 5 records that we have, indicating either 0 or 1 as an output. All right, okay, so to summarize, what we have learned in this project is that we have learned how to use DataRobot, and literally in less than 20 minutes, we have been able to train multiple models. Actually, I've been able to train 14 models automatically without writing a single line of code. We even wrote them in different languages. And we have been able to also assess the performance of our classified models. And we have been able to deploy as well the best model out of all of them. And that's it. That's all I have for this project. I hope you guys enjoyed it, and see you in future projects.